Hello everyone, welcome back to another session by K21Academy. Today our expert trainer will be discussing horizontal pod autoscaling using the 2048 game as an example. So please watch the video till the end.
This is the application which is deployed. I've exposed it to the outside world. Some random game, right? It's a 2048 tile game. It's pretty popular, right? Now I've deployed it and I have multiple replicas and I've exposed it to the outside world. Of course, we don't share the IP address and the port number to the end users. We all know before we deploy our application to the outside world, you need to put them behind a DNS server. You need to run a web proxy at port 80. That's what we do, right? So if you don't really give the IP addresses, you don't expect your end users to remember the IP address and port number. But those are the additional steps what you need to do when you deploy applications to production. That's outside the scope of Kubernetes for now. But the point is, this application is exposed, assuming we have some URL set here, some DNS name. And now I have 5 copies of it. And there are 1,000+ users accessing this game. And suddenly this game becomes viral, pretty popular. And now millions of users start accessing it. What's going to happen? Well, what's going to happen is this one guy, these 4 replicas are not enough. Not enough per se is maybe, a million users are accessing 5 copies of them are able to, take over the load. But the game becomes viral and now hundreds of users, millions, thousands of users are accessing it. These guys are going to get back down. So what do I need to do? Well, I need to add more copies, increase the replicas. And so far, whatever we have learned, the replicas, what we did was scaling up manually. 2 o'clock in the night, there's sudden surge. You don't expect me to log in and increase the count of replicas. What can we do? Well, Kubernetes has a solution for you, and that's called as horizontal pod autoscaler. HPA, as we call it in short. Horizontal pod autoscaler. What does this guy do? Well, we create another controller which sits on top of any any controller which you can scale. You hand over the scaling part to that. I've copied this from the documentation. So you create another controller called as HPA and you give the scaling behavior of that particular replica set or deployment to HPA. Now HPA sits on top of the deployment, keeps an eye. Of course, you need to tell that as part of your desired state, when to scale, what to scale, and stuff like that. So what do you need to mention? You need to mention few things to HPA. So you're asking somebody else to keep an eye and scale, but somebody else is HPA in our case, right? So when you create the HPA, first thing you tell is there can be hundreds of deployments out there in your cluster. So you need to give which deployment am I talking about. We need to give a scale, a target reference, telling that there is a deployment called as game. That is what I'm talking to you about. Keep an eye on this guy. Fine. I'm going to keep an eye on that guy. Then when do I scale? What is the trigger point for me? You want me to add some replicas, increase when the load increases, correct? So you need to give me some threshold. Some threshold. What threshold? Well, until the version 1.22, the only option, HPA, what was in the version V1 of the API resource there, it had only one field called as target CPU utilization. The CPU utilization of the pods combined, of all the pods combined of this deployment, is going to take that into consideration. Default is 80%. When the CPU utilization goes above 80% of these pods, that means CPU utilization is directly proportional to the number of requests what your application pod is handling. Right now, if I go look at CPU utilization, maybe it's 0 because there's no requests at all. So if you have millions of users accessing and millions of requests, there's a lot of context switching, your CPU utilization goes up, right? So you give that as part of your desired state when you create a HPA. You tell, listen, at this particular threshold, maybe 50% when the CPU utilization goes above 50%. Scale up and do what? Well, scale up and add more replicas. Now, I've mentioned the threshold as 50%. So as long as the CPU utilization of all the pods which is being managed by this deployment is under 50%, the HPA is not going to do anything. This is my desired state. Till 50%, you don't need to do anything. If it breaches 50%, maybe it goes to 60, maybe it goes to 70. You need to do what? You need to start adding more pods. You need to start adding more pods and then collectively try to bring down the CPU utilization to below 50. Say, for example, if I had only one pod and then the CPU utilization went to maybe 80, right? So there's an algorithm though, I'll go show that algorithm to you. That the algorithm is, your current metric value divided by desired metric. Current is 80, desired is maybe 40, for example, for division purpose, if I keep it simple, it's going to show you as 2. So 2 is the number of replicas what you need to add so that, if the CPU utilization goes to 80 and if there's only one pod replica there, if you add 2 of them, the load can get distributed, the CPU utilization to come down to 40. So there's an algorithm, we'll look at that. But the point is, whatever you need to do, how many ever replicas you need to add them. Add them to bring the desired threshold to whatever I have. So if it goes to 70, 80, 90, meaning that number of pods what we have is not able to handle this load, bring it down to 50. So bring it down to 50, what do you need to do? You need to start adding more pods, meaning scale up, right? And now, I do not, say for example, if you have a denial of a service kind of attack, where you're constantly being bombarded and constantly being hit, that threshold is going to go, no matter how many pods you keep on adding, the CPU utilization is not going to come down to your threshold. So I want you to scale up, but I don't want you to infinitely scale up and max out my cluster resources. So what I do is I give the upper limit as well. That's called the max. I want you to scale up, keep on adding pods, 1, 2, 3, 4, 5, 6, 7, 8, whatever pods you want, to bring that threshold to my desired value. But for some reason, you can't bring it down. Don't infinitely keep scaling up. I know my application, it does not need to go up beyond 10 replicas max. So I give a upper limit. It tries to scale up from whatever count you have to the max value. And if even beyond max, it's not able to bring it down to the threshold, it is going to ignore it. Similarly, when everything is fine and there is no, everything is beyond the threshold, what is the minimum number of replicas I want you to manage? I will set that to minimum number. Maybe I will set it to 2. For any given point of time, I want 2 copies. When the threshold is under 0 or 0 to 50, keep the minimum count. So the scaling part, I will hand over to another controller called as HPA, and I give these 4 options to him. He's going to look at that, which deployment, what threshold, and it's going to scale up gradually, try to add more pods to bring it to the desired level. If it is not able to do that, it will stop at the max level. When everything is fine, it will maintain the minimum replicas what you've asked for. That's your HPA. That's how you're going to create another controller called as horizontal pod autoscaler. Let's go take a look at that. But one thing is, for HPA to work, it needs to have some metric value. The metric value here is the CPU utilization. So how can I get that metric value? That opens up another question is, what kind of monitoring do I have available out of the box in the Kubernetes cluster what I have set up right now? The answer for that question is, I do not have any monitoring going on right now. Because when you make use of kubeadm to set up your cluster, there's no monitoring involved. This monitoring needs to be an additional item on top of it. Kubernetes supports various different tools per se. There is a metric server, a very lightweight application which can monitor the 2 basic resources you have, like memory and CPU. But again, that is not installed or deployed by default. You need to deploy it. Or there are other tools very quite popular. There's Prometheus, which is very popular. You need to, again, it's not installed by default when you set up kubeadm cluster. You need to add on, create a deployment, create Prometheus as a deployment, and you need to enable monitoring on top of it. Or you can make use of Elasticstack. There are paid versions like Datadog, Dynatrace. There are many of them available, and Kubernetes has support for all of them. There are images of those available. Few of them are open source. Few of them are paid versions like Datadog and stuff like that. You can set them up. But there is a monitoring server which is available for you. Of course, it is not deployed by default, but there is a monitoring server called as metric server. So every kubelet, which is running on every node of your cluster, has a subcomponent called as C-Advisor. C-Advisor stands for Container Advisor. It's an open source tool. When you're running standalone Docker, you can also install that. What does this guy do? This guy captures your CPU and memory utilization, 2 basic requirements. This is a metric server. It's a very thin, lightweight, in-memory kind of an application. which is provided to you by Kubernetes. You can make use of that. It's not deployed by default. You can deploy it. It's going to talk to your kubelet on every node, and it's going to capture the memory and CPU. This metric server is not stateful, meaning it does not store anything on the database. It does not tell you what was the CPU utilization 20 days ago. It's not going to tell you all of that. It's going to show you what the current memory and CPU utilization is. So you need to have the HPA to work. It needs the metrics to be running. You need to have some monitoring going on there. So you need to have the metric server installed. We need to do that right now, which is not installed in my machine right now. So there's another command called as CubeCat top that also makes use of your metric server. So if I say CubeCat top and show me the CPU and memory of the nodes available out there, it's going to come back to you and complain metrics API is not available. So if I take you to the documentation, and if you look at metrics server, it tells you can, metrics server fetches metrics from kubelets and exposes via metrics API. CubeCat top command can work with it. It tells you it is not installed by default. You can do so by visiting the GitHub and downloading it. There's a URL here. It talks about what metric server is. Tells you it is very resource efficient, takes only 1 millicore of your CPU, 2 MB of memory, and what it does, it collects metrics every 15 seconds. And support up to 5,000 nodes in a cluster, and you can just deploy it this way, and your metric server will be installed. So right now, when I came back, when I did the CubeCat top node, it says metrics API not available because the metric server is not deployed. Let's go ahead and deploy the metric server real quick. Copy the same YAML file what we saw in the documentation, and it deployed something. If I quickly go back and do CubeCat, get pods in the namespace cube system. We see the metric server is in the container creating stage. We can also do -watch. It's currently running but not ready. It's going to come back in the ready state in some time. But anyway, the point is we've deployed the metric server. Now when I go back and I do CubeCat top nodes, now it does not tell you metrics API not available like the way it did earlier. Now it's telling you some other error because the metric server is still not up yet. It's still not come to the ready state to accept the traffic. And once it comes up, it's going to take 15 seconds to go scrape the metrics. So the CubeCat top command is working because we have installed the metric server. Good. Now, this is also another important interview question. Not interview, the exam question as well. So this top command works with respect to the nodes, the pods, and the container level as well. So I can do CubeCat top pods as well. So it's going to show you at the pod level, the memory and CPU, right? And if I have multiple containers, like for example, top pods -n cube -STM. So for example, view of net has multiple containers, has 2 containers in it. So if I want to look at the container level, it's going to show you that value at the container level as well. Like in the pod, I have multiple containers. I want to look at the CPU memory utilization at the container level. You can. You want to look at the pod level, you can. You want to look at the node level, you can. So the top command shows you nodes and pods. All right. Additionally, it also has option like sort by. I can do -sort -by equals to MEMORY. It's going to sort them. Why are you showing all this stuff? Well, like I told you, the exam is going to be a combination of questions which take less time and questions which take larger time. There can be a simple question that says, hey, okay, listen, in this namespace, there are 20 pods running. Can you tell me which pod is consuming highest number of how much highest memory? So for example, if you run the top command on the namespace, maybe everything looks something like this. Everything showing as 15, 18, 15, 19, 16. When you look at it with the naked eye, everything looks the same for you. So in scenarios like that, if you have a question, there can be a question out there. You can just do sort by memory, or if the question's around CPU, you can sort by CPU. It's going to sort it out for you. Here, of course, 234 is right up top. We can identify. If there's a question, if I ask you a question, which is the pod in this particular namespace consuming highest number of CPU or memory, your answer is this question, this pod name. So you need to take the pod name and write that pod name as the answer to that question. So that from that point of view, top command is what I showed you a little bit in depth, but we came here looking for the HPA. All right, let's go and look at the HPA. For HPA to work, I need to have the metrics, and we installed the metrics. Good. Let me quickly clean things up. CubeCat, delete all. Let's go look at the HPA right now. So for HPA to work, what do we need? We need a deployment to be created. Let me quickly get the Deployment YAML. I'm going to create a YAML file. Deployment CubeCat apply from file web app.yaml. We've created a deployment. Let me open the deployment. Let's look at the deployment. I'm going to delete few lines here. This is the regular deployment what we have seen so far. Okay, we have spec, we have replicas, we have selector, and we have template. Right, the regular deployment. So let me undo the lines what I deleted. Now we're getting introduced to a new concept. New concept of what? Of resources. So optionally, you can specify resources what your container needs. Most common resources what you have are CPU and memory. I have seen this somewhere. Yes. Let me save this. Let me go back to the Docker world. When I was running the container, Docker container run, ask for help. We made use of something. What? Hyphen memory. Remember? By default, your container can consume as much as memory available on the node. By design, we don't want that to happen. Why? There's a badly written code, there's a memory leak, there's an attacker who got access to the container, he's copying up all the memory of that container. Well, that container is going to consume all the memory on the node. The other containers, other processes on the server are going to starve. We don't want that. We understand our application. We know our application does not need a memory certain beyond a certain limit. So when we ran our containers, we made use of hyphen memory or hyphen M as an option, and we set the upper limit. So beyond this limit, your container could not make use of the memory. So what happened when it hits the limit? Well, based on how you have defined your application, maybe out of memory exception and stuff like that. Similar, you had something else, hyphen CPU, where you could define how much of CPU your containers can make use of. By default, they can make use of as much as the CPU available on your host. Right? That's when you ran your containers, specify some options with memory. You had the memory soft limit as well. Reservation, that amount of memory will be reserved for you. Now, back to the Kubernetes world. Same containers are what we're running. So far, what we ran without any limits. So now, the way you restrict that CPU and memory in the Kubernetes world by another keyword under your container spec. Not under your pod spec, under your container spec. You see under your spec containers is where you have, because you need to specify these limits at every container level, right? So we have two ways of doing it. We have resources, we have under resources limits and request. And there are two resources. There is your MEMORY, colon in double quotes. Memory is represented in bytes, kilobytes, megabytes, gigabytes. And CPU is in millicores. And again, it is also M here. Well, memory we understand is in bytes, kilobytes, megabytes, gigabytes, right? CPU resource units are called as cores. One physical CPU or one virtual CPU is 1024 millicores. Well, here M here stands for millicores. That means if I had one CPU, 100 milli is nothing but 10% of CPU. So this particular container can't see beyond 10% of CPU, meaning the 10% of my CPU of that host is equivalent to 100% CPU for this container. CPU is in cores, memory is in bytes. We understand that resource units concept. I'm going to deep dive on that, right? So there are two ways of defining it. What? Under resources, you have limits, you have requests. What are these two? Well, first, let's look at the request. So when you specify resource request for a container in a pod, this information is used by two people. First, it is used by Kube scheduler. So far, the scheduler was doing whatever it was doing, right? We never told my scheduler to do what we wanted to do. We are getting introduced to certain things. When I'm telling my scheduler, listen, dude, put me onto any node, I don't care. As long as that node has this much amount of memory for me or this much amount of CPU for me. So scheduler makes use of this information to decide which node to place you on. So it's going to look at the hundreds of nodes what you have. It's going to search for the nodes which has at least this much of resource what you have asked for is available there. It becomes like a filtering criteria for your scheduler. Of course, if the 100 nodes, 500 and after 150 nodes are having this capacity, it's going to filter those 50 and it's going to rank and score and choose any one of them based on which gets the highest ranking. But I gave the filtering condition, that's your request. That's point number one. Scheduler makes use of this information. Good. And whatever you've mentioned under the limits, that's your upper limit. Your container can't make use of beyond this. Kubelet on that particular node is going to enforce this limit. So your container can't see beyond this. What happens? Well, what happens if you're running your application and your CPU reaches 100% and it's stuck there, right? Same story. Memory, same story, gets killed usually with out of memory exception, OAM, right? The limit is enforced by kubelet and your container is not allowed to use beyond what is the limit. Request is made use of by two guys. First guy is the kube scheduler, which uses his information to decide which node to put you on. And then what it does when it goes to a particular node, kubelet what it does also reserves the requested amount of that resource for especially for your use only, for your container use. It's going to do a soft reservation out there. That is your request. So I'm going to undo what I've added. Here in the HPA, I kind of introduced you to this concept to show you the scaling part, because by default, that container can consume as much resources. I can't add that much load to scale up automatically, but we wanted to introduce you a new concept. How do you restrict your limits and how do you do soft reservations? And you tell your scheduler where to put you is with the help of resources under your containers. Under resources, you say limits and requests. The two kind of resources, your memory and CPU. Memory in bytes and CPU in your codes. All right. But we came here to look for HPA as a concept and we got introduced to something else, something new. Good. So I'm going to create this deployment right now. I think we did already created this. Can we get on? So we've created a deployment which has 3 replicas and that requests what we have set. Right. Life is good. Fine. I need to create a service for this to access it. Good. So what do? We learn the expose command. It's very easy to create a service. We'll say CubeCat will expose a service, a deployment. What is the name of your deployment? Here's the name of my deployment. And what is the port number for my service? Well, whatever I want. What is the name of the service? If you don't mention this option, the name of deployment will be the name of your service. I will say create me a service, whatever name, right? And I will say maybe create me a type is equal to node port because we have learned that. Of course, I can do expose and help. It shows me all the options. I'm just showing you a few. Easily, I was able to create a service. Good. Now, CubeCat will get all. We also have a service node port created. This is the port number what has been given to me. Good. So if I say in my etc host files, I've added kube node 1 as an entry. And if I say this port number, I'm able to access that application. Fine. Now we need to see the HPA. Let's create the HPA for this guy. Let me download the YAML file for my HPA. Timed as horizontal pod autoscaler. The group belongs to autoscaling. The version is V1. In the new versions of the Kubernetes at 1.23 onwards, 2.3, 2.4, 2.5, the version of autoscaler has been upgraded to V2. V2 has more options what you can specify. V1 is only one option what you have called as target CPU utilization percentage. Well, under the HPA spec, there are 4 things, which is the target reference. Hundreds of deployments. Which deployment you want me to scale up? Well, there is a deployment which belongs to apps as a group version V1. Name of this guy. This is what I want you to keep an eye on. I'm telling my HPA. And I'm telling what is the CPU utilization. Default is 80%. And I want the scale up to happen faster. I've mentioned 20 as my default. So it needs to ensure at any given point of time, the CPU utilization of those pods out there collectively is below 20%. So do whatever you need to do. Add as many as replicas as you want to bring it down to below 20%. But I don't want you to max out my cluster resources. I don't want you to infinitely scale. Maximum you can scale up to 10. Beyond that, well, don't do anything. I know my applications max 10 should be enough. When it is all under 20, under the threshold, life is good. I want you to maintain minimum of 2 replicas. I've mentioned that. I'm going to create my HPA. CubeCat will apply from file hpa.yaml. My HPA got created. Very nice. CubeCat will get all. And I have HPA also created here. That HPA is referencing a deployment name as web application. And right now it's telling I don't know what is the current CPU utilization. Because when you deploy an HPA, HPA is going to go scrape your metrics. You already have exposed your metrics API. You have installed your metrics API server. And it's going to scrape this metrics every 15 seconds. Can we change all of that? Of course, we can change all of that behavior. Default is 15 seconds. You don't want it to keep on scraping your metrics and slow down things. That's why the default value is set to 15 seconds. So it's going to take some time, like 15 seconds. If we come back and look at it, now it has captured what is your current metric value. Now these pods of this deployment currently are consuming 0% of CPU. Nobody's accessing it. So we need to do what? Add some load. How do I do that? I need to access that application, correct? So what will we do? We will make use of a tool called as Siege. It's a third-party tool. I'm going to run that. And I have installed a tool called as Siege. It's a regular tool, general load testing tool, HTTP-based load tester that is. And just to add some tool load out there. So if I quickly do CubeCat, I'll get all. This is the port number what I have, correct? So what do? If I make use of the tool what we have installed called as Siege, and I say concurrently, is the quiet mode, don't give me any verbose output. Concurrently as 5 users for the time of 2 minutes. I want you to hit this URL. That URL is cube-node 1 and the port number. Any node name, node IP you can make use of. I can make use of my node name because I have added that IP address in my etc host file. Otherwise, you can make use of node IP. You can internally, in the cluster, I can make use of cluster IP and this port number, node name, node IP, and this port number as well. So what's going to happen is going to hit this URL for 2 minutes straight as 5 concurrent users. The moment you hit this, what's going to happen? It's going to say, welcome to Nginx, 200 response, right? Maybe it takes a milliseconds. And then it's going to bombard it with the same request. So it's going to do in this 2 minutes, maybe, a couple of thousands of transactions. So in a way, what happens? All of my pods are going to get busy. The CPU utilization of those guys is going to go up. We have capped the CPU utilization. Little bit of CPU spike there. That's going to cross the threshold of 20%. And we'll see the scaling up happening. Let me enter. Siege right now is running. Let me come back to other screen. What we have. This matrix is scraped every 15 seconds. Right now, it is showing as 0%. So after 15 seconds, it's going to come back and go look at the metrics. Now that we are bombarding it, constantly hitting this guy, the CPU utilization is going to go up slowly. You see the CPU went up to 18% right now. Still not enough to trigger the scale up. Beyond, it's still below 20%. Still, it's not going to do anything. It's still going to maintain the same replicas. So we're still constantly hitting it. And now we see this metrics jump to 36%. So it needs to add more pods to bring it to 20%. So it realized I need to add 3 more replicas and 4 more replicas. You see 4 more replicas were scaled up.
So guys, this was our expert from team K21Academy, and if in case you want to have a deeper dive and want to build a career in Kubernetes and Docker, including DevOps, then we have something really special for you. We have our free class on mastering Kubernetes, Docker and DevOps that includes how to build in-demand skills and land a higher paying job. So for that, you just have to visit k21academy.com/K8S02. You have to click on book your free seat now. And after that, select an event date according to your availability. Enter your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface. You just have to save this link on the extreme right, add it to your calendars, and I'll see you in the free class. Till then, take care and keep learning.